We all know that IP version 6 is coming within the next few years since 1996. At least we have quite good penetration depending on the country, 30, 40, 50% in Germany, only some few percent in Sweden, somewhat more in the US. But still there's a way to go. So what happens if we look at mobile IP? It was developed for IPv4, but IPv6 really simplifies the protocol. So all security issues, they are now integrated. We don't need these add-ons for mobile IP. Authentication, registration, that's all included. The care of address, well, this can be assigned via so-called auto configuration. Please have a look at the computer network lectures. And all nodes know how to handle this. The routers, they perform router advertisement, so we don't need a special agent advertisement. So there's no need for a separate for an agent. All routers know how to do this. Addresses are always co-located, so the mobile nodes know how to handle this. So the mobile nodes can also optimize the path automatically by sending the sender, your corresponding node, directly the care of address. So you do not have to send via the home agent. But again, what about privacy? And so in the end, you can offer something like a kind of a soft handover. If you move from one subnet to another subnet, the mobile node sends the new care of address to the old router. We saw this example in mobile IP version 4. Now it's all integrated, and automatically the old router knows how to encapsulate the incoming packets and how to forward them to the new care of address. So that's quite nice. And this is also, or these are the basic mechanisms also used in the mobile phone networks today. Okay, that's nice. But what happens if you move from subnet to subnet to subnet? So what happens if you change your subnets frequently? You have to involve your home agent each time. And this also reveals your location. I told you this already. So the idea is, why not supporting micromobility in a special way? Micromobility, that means maybe you change from the subnet from chemistry to computer science to math to physics. So then why telling the home agent in a completely different country that you do this micromobility movement and changes? So micromobility, that means you efficiently support these local handovers without involving the home agent. Reduce control traffic, that's the main idea. So there's a lot of research there. There were several approaches, not really many products. And the problem is always how to support security, scalability. Is it still transparent? And I will just give you one example, because this is also a standard. One example for this is the Hierarchical Mobile IP version 6. So the idea here is you have the internet, and somewhere in the internet there's your home agent. And then the network contains a mobility anchor, so-called map. And this mobility anchor now maps the regional care of address. And that's the care of address you will see outside. Let's say that's your campus network here. Outside of this network, you will see this regional care of address. And the map now will map this R care of address to your L care of address, the link, the local care of address. So, and if you now perform this handover from one subnet to another one, you only inform this map. That's all. No change visible to the outside network. That's the idea. So you have your access router and your traffic flowing here. You have your old address that fits to the old subnet, and then after moving to the new subnet, you will get your new address. And here the mapping is performed from the outside care of address to the inside. And the tunnel now ends here at the map. That's the idea here. So the binding updates, yes, they should be authenticated, but anything else, so you don't have any additional security provisions here. So that's a simple thing. Big advantage, the local addresses are hidden. So at least you have some location privacy. That means outside, maybe everyone sees, well, you're now on the campus of some university based on the subnet of the R care of address. But no one notices if you're at physics, chemistry, or whatever. So that's the idea. There are even ways described of how correspondent nodes can share same links, direct routing to optimize this. But more important, this scheme requires only a minimum number of changes in routing tables. So if you perform a handover, well, that's an easy thing. No one notices outside of the network. There are some problems. It's not really transparent to the mobile nodes. Remember, care of address, you have to manage them on the mobile nodes. The mobile nodes, they must directly influence routing address, so they send these binding updates. Binding updates just send an update to a router performing this mapping. That can be dangerous, so you have to authenticate them, because if you send this kind of malicious updates to a router, then the router is completely confused. So that's the point. And if there are some wireless scenarios in between the reconfiguration, routing, etc., they are sent over the wireless link. So there are some disadvantages. But that was basically an idea, and that's what you should at least remember, idea of separating this macro mobility from a micro mobility. And many of these ideas, they came together to a standard that is now used inside mobile phone networks. And this is called the Proxy Mobile IPv6 or PMIPv6. And this is now a network-based mobility management protocol. So not the mobile nodes do anything, but the network. So the idea here is you support IP mobility, that means mobility on layer 3, without any participation or mobility related signaling or whatever from the host, the mobile node. The mobile node has to do nothing. So the network manages the mobility. No software change in the clients. And this is exactly what you will find in LTE networks. There is a so-called local mobility anchor, and this LMA is in the packet network gateway. So this local mobility anchor acts as a home agent. So this is your home agent, and the mobile node is your, let's say, your mobile phone. On layer 3, your mobile phone is the mobile node. Different terminology, but that's the idea. Mobile node. And this is your home agent, the local mobility anchor. And that's the anchor for all your network prefixes. Maybe you have several, or at least your prefix. So that's where you belong to. That's your home network prefix. And then you may move from router to router in the, well, we have the evolved packet core, 3GPP, the network. That's just an example. So the standard works without the 3GPP. This is just the application of the standard. So, and maybe you move from one mobile access gateway to another one. This mobile access gateway works as access router. So that's the first router towards your mobile phone, for example, tracking your mobility. And this router performs all the signaling in the network with the local mobility anchor. So here you do all the mobility management on behalf of you. You don't have to do anything. If you know mobile IPv6, fine, but you don't have to. That's the idea. What else can you do? And this is what the operators like. If there's a Wi-Fi network close by, then you can offload traffic via this Wi-Fi network. That means the mobile node notices there's a Wi-Fi network, that layer 2, but there's also a router. This router is again the mobile access gateway, which can now tunnel the data to the local mobility anchor, and from there it can reach any corresponding node. There are also options where you can directly send some of the traffic directly into the internet. So IP traffic offloading is possible. That means if you have a very crowded, for example, LTE network somewhere downtown, but there are Wi-Fi hotspots, you can easily offload some of the traffic with your mobile phone, and you will not notice it. As long as you have wireless LAN connectivity and LTE connectivity, you don't care. The traffic somehow flows from your mobile phone into the network. Okay, what else can we do to support mobility? One final idea. Think of what is an IP address. You might think, I know what an IP address is, but what is the role of an IP address? I told you IP addresses have to be topological correct. Otherwise, we cannot route and forward traffic to a node. That means IP addresses are important to localize a node. Otherwise, I cannot find it. Forwarding packets needs routers. Routers check network prefixes and forward the data. What else do we do? With the IP address as part of the socket, but also as a part of, identification of this is my interface, unique, worldwide. So that's the second role of an IP address, is the identification of a device. But we use only one IP address with two roles, and the idea is split the roles. And one standard for this is the host identity protocol, using a separate layer between routing and transport. So that's between 3 and 4, somewhere in between. Can be alternatively used to mobile IP. And this protocol uses the IP addresses for routing only, so only for this localization role. And these IP addresses, they change because they have to be topologically correct, otherwise it doesn't work. The identification, this is where the protocol uses so-called host identity tags. And they are used for the TCP connection, so inside the socket. We use now host identity tags instead of IP addresses. They are based on public keys. There's some key exchange involved. We'll not go into details. The big advantage is it's a normal IP routing because, so normal routing stuff. There's no intermediate agent, nothing needed, but there's some extra time needed for the key exchange. Firewall problems might be many more RFCs. The main problem, it's an extra layer. So we need a layer between routing and transport. That means we have to change something in all the end systems. There's discussion if this is the right way to go. There's another idea. It's called Locator ID Separation Protocol, LISP. And this is basically a new routing concept. Uses some tunneling for data transfer, but does not require any changes to the host and to the core. So it uses two IP addresses. One is called a routing locator, and that's the topological assigned address. It's all the format of an IP address, but the semantic here is it's the used for routing, this part. And then there's another address, syntactically also an IP address, semantically it's the identifier. And this is something you can assign as administration, and this is used for identification. So if you're interested in this, please look it up. Here are the pointers. Some questions. How does IPv6 simplify mobile IP? There are some simplifications. Why is maybe micromobility support a good idea? Why do we need it? What is the big advantage? Then there's a solution called Proxy mobile IP version 6. What is the advantage there? Where is it used? And finally, you should at least know the two different roles of an IP address. Why can this be problematic, and what are, at least at a certain higher layer, level the solutions. If you're interested in details, you have all the pointers there.